Okay, so moving on to Unit 10, today we're going to talk about derivatives of exponential functions. So we're looking to understand how to find the derivative of an exponential function. So first we're going to look at e. So e is what we're going to be focusing on today, or base e is what I should say. So you may or may not remember way back first semester when we started doing exponentials and logs, and I showed you that the limit as h goes to infinity of 1 plus 1 over h to the h is going to be one way in which we can find e. Now at that point, that was first semester, so we didn't really know limits. I told you just to take my word for it. I also showed you that the limit as h goes to 0 of 1 plus h to the 1 over h is e. Again, this was just kind of showing you a couple of ways in which we can find the actual numerical value of e. Both of these these are two ways. This one down here, this also came up in one of your homework problems at the very beginning of chapter 3 when we first started doing limits. And you had the limit as h goes to 0 of 1 plus h to the 1 over h, and it comes out to be, at that point you only knew how to do it numerically, so you got the decimal approximation of e 2.7 something. But so these are how we get e. So with this in mind, looking at this version of e, I want you to try to use the limit definition of the derivative. So remember, we're going to find the limit as h goes to 0 of f of x plus h minus f of x over h. So f prime of x equals this, and I want you to do this when f of x equals e to the x. So I want you to pause the video and try to do this on your own. Again, you're going to have to use this limit definition from before. Unpause when you think you have your answer. If you get stuck, same thing. Okay, so you should end up with the derivative of e to the x is e to the x. And if you didn't get that, I know you're thinking, whoa, 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 wait a minute. How does that work? That doesn't make sense. The function is its derivative. What does that mean with the second derivative? Wait, mush, brain all over the floor. I know, I get it. So let's look back and see how this happened. So if we go back up to the top. So we're using the limit definition of the derivative. So we first plug in the limit as h goes to 0 of e to the x plus h minus e to the x over h. Using properties of exponents, I separate e to the x plus h into e to the x times e to the h, and I still have minus e to the x over h. Now I can factor out an e to the x in the numerator, so I have e to the x times the quantity e to the h minus 1. Now, here's where we have to use the limit, one of the limit definitions of e. So we're using this here. So we know that e is the limit as h goes to 0 of 1 plus h to the 1 over h. So basically e is approximately 1 plus h to the 1 over h when h is really small. So if I raise both sides of this equation to the h, then this cancels and I get e to the h is approximately 1 plus h when h is really small. Basically when I'm taking the limit as h goes to 0. So I substitute in for e to the h, I make it 1 plus h. Crazy, I know. 1 and 1, or 1 and negative 1, those are going to cancel, so I'm left with the limit as h goes to 0 of e to the x times h over h. The h's cancel, I'm left with e to the x. So the derivative of e to the x is e to the x. The derivative of e to the u, if u is a function of x, is e to the u times du dx. So that's just using the chain rule. So let's look at an example. So these are, going back real quick, these two are things you're going to want to know. You should memorize the derivative of e to the x is e to the x. The derivative of e to the u is e to the u du dx. So if I have f of x equals e to the 3x squared minus 2x, and we want to find the derivative. We're first going to do f prime of x, so this is e to the u, basically, and so this is going to equal e to the u, which is just 3x squared minus 2x, times the derivative of 3x squared minus 2x, so 6x minus 2. Bam. That's it. I want you to find the derivative of f of x equals e to the negative 3 over x. Pause the video, unpause when you're ready to check your work. Okay, so f prime of x is going to equal e to the negative 3 over x times the quantity 3 over x squared, which is the derivative of negative 3 over x. And if I want, I can rewrite that as f prime of x equals 3e to the negative 3 over x all over x squared. Either way is fine. It's the same thing. So now let's look at using this derivative. So I want you to find any relative extrema. So if f of x equals x, e to the x. I will give you a hint. You do need to use the product rule here. So find some extrema of this function. Pause the video. Unpause when you're ready to check your work. Okay, so we have a relative minimum at the point -1 over e. How do we get that? Let's go back up to the top. First, the derivative, f prime of x. We have to use the product rule. The derivative of the first is 1 times the derivative times the second, which is e to the x, plus the first, which is x, times the derivative of the second, which is still e to the x. Set the derivative equal to 0. Factor out an e to the x. Set each factor equal to 0. E to the x doesn't ever equal 0, so that doesn't give me any critical values, but x equals -1 is a critical value. I chose to use the increasing decreasing chart from the first derivative to test this. You could use the second derivative test. I believe that'll work in this case as well. So I have -1, I plug in -2, I plug in 0. -2 is negative, 0 is positive. So using my derivative speak, since f prime of x is less than 0 on negative infinity to -1, and f prime of x is greater than 0 on -1 to infinity at x equals -1, is a relative min. So then I found the y value of that point by plugging it into the original function, and I get my relative minimum is -1 over e. Okay, so find any inflection points. Pause the video, unpause when you're ready to check your work. Alright, so we should end up with 2 inflection points. One of them is at the point 1e to the -1/2, and the other one is at the point -1e to the -1/2. So how do we come up with that? Well, first, if we do the first derivative, f prime of x equals e to the -x squared over 2 times -x, because that's the derivative of -x squared over 2. And so then I do the second derivative. I have to do the product rule. So the derivative of the first, which is e to the -x squared over 2, and I know that the derivative of that is e to the -x squared over 2 times -x, and then times the second, which is -x, plus the first, e to the -x squared over 2 times the derivative of the second, which is -1. Simplify this a little bit, so the left term becomes x squared e to the -x squared over 2, and the right term becomes negative e to the -x squared over 2. Factor out an e to the -x squared over 2, and set the function equal to 0. When I set e to the -x squared over 2 equal to 0, that's not going to give me any possible points of inflection because that's not going to equal 0. But x squared minus 1 equals 0 tells me that x equals 1 and x equals -1 are possible points of inflection. Then I use the increasing decreasing chart for the second derivative to find if those are actual points of inflection, and they both are. So I use my derivative speak to say that. And then I find the y value by plugging in 1 and plugging in -1, and it is the same y value. Therefore, I get my inflection points of 1 e to the -1/2 and -1 e to the -1/2. Good stuff. One more. So I want you to find the equation of the tangent line to the curve at the point 0, 1 for the function y equals e to the x over x plus e to the x. Pause the video and unpause when you're ready to check your work. Okay, so I should end up with the equation of the tangent line at the point 0, 1 is y equals -x plus 1. So how do we get that? Well, first we do the first derivative, so I have to use the quotient rule. So bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Now I plug in the x value of the point, so I plug in 0 for x, and all of that simplifies to 1 minus 1 minus 1 over 1, which is just negative 1. So negative 1 is the slope of the tangent line, and since I already know the y-intercept, it's really easy for me to write slope-intercept form. So I can do y equals negative x plus 1. Okay, so what we need to really make sure we understand, or the only thing that was new in this lesson, I should say, we need to understand everything, obviously, is the derivative of e to the x is e to the x. And if if it's not just x, if it is some other function with respect to x, then d dx of e to the u is e to the u times du dx, so using the chain rule. Something else to think about is, what if the base was not e? So what if it was like 2 to the x? Is the derivative still 2 to the x then? Think about it. I know, right? Also, it's great to see, I know you're super excited, that just because we're doing exponentials and we'll be doing logs in a little bit, we still need to know and understand all of the other things we've learned about derivatives. Finding maximums, minimums, inflection points, tangent lines, all of that good stuff still applies. We just have other functions that we can deal with now. Fun. I know. Have a good night.